Okay, now we're ready for practice test 2. So we got our papers out. We're ready for practice test 2. Here we go. Let's get a brand new marker out. Big occasion, practice test 2. Here we go. We're going to sketch this guy, and our equation is 2x squared minus 18 over x squared minus 7x plus 12. All right, here we go. We know what to do. We've done these before. Step 1 is we want to get it factored. So we can take a 2 out of the top. So my top is going to factor with the 2. You must bring that along with you. X plus 3, x minus 3. Over x minus 3, x minus 4. So there is the complete factorization for problem 1, practice test 2. Notice, woohoo, we have a cancellation. So we are going to end up sketching, don't forget the 2, don't forget to bring him along. We're going to end up sketching this. This is the problem that we're going to sketch. Because we canceled out that factor, though, we know we're going to have a hole where x is 3. There's going to be a hole in this picture where x is 3, because that's the factor that we canceled out. So I'm going to go ahead and put 3 in, so I get 2 times 6 over negative 1. Oh gosh, I got negative 12 if I put in 3. So I'm going to plot the point. Oh boy, I'm just about out of room. It's way down here. 3, negative 12. Way, way, way down there. Now, what else am I going to put in here? Well, I know I'm going to have a vertical asymptote where x equals 4. So there's a vertical asymptote at x equals 4, because that's what makes my denominator 0. I know I'm going to have a horizontal asymptote at 2x over x at y equals 2, because that's how I find horizontal asymptotes. I put x over x, and I happen to have 2x over x, so my asymptote's at y equals 2. I have an x-intercept. Now remember, x-intercepts happen when you let y be 0. And what you ultimately end up doing when you let y be 0 is solving the numerator. What would make this 0? Negative 3. So I'm going to have a 0, an x-intercept at negative 3. X-intercepts come from your numerator. Every time they come from your numerator. And then a y-intercept, I'm just going to go ahead and put 0 in. So if I put 0 in for x, I'm putting 0 in for x now, I'll have 2 times 3, which is 6, over negative 4. So negative 3 halves. So negative 3 halves is my y-intercept. Okay, one more time. X-intercepts come from the, x-intercepts come from the numerator. What makes the numerator 0? Y-intercepts, let x be 0. Vertical asymptotes, what makes the denominator 0? And horizontal asymptotes, x over x. Now, let's connect the dots and see what we have going on here. Pretty easy to tell with the points that we have here that this is what it looks like. But that's only half the picture. Don't forget, these guys are variations of the reciprocal function. And so if you only have 2 asymptotes, if you only have 1 vertical asymptote, which is all you're going to have on your test, 1 vertical asymptote, then your curves are opposite each other. So you're going to have a piece of the graph up here in the upper right corner. as we're going through practice test 2, if I'm going too fast, if I say something you're not sure of, remember you do have written out solutions. You can hit the stop and rewind button, or you can lean over and ask your neighbor. So don't just give up. Push through. You can do this. Page 2. Remember when we do inequalities, and now we've got a whole page of inequalities here. When we do inequalities, we are going to draw a number line. We're not going to do this kind of stuff. We're going to draw a number line, and we want our inequality set equal to 0. So, I'm going to set it equal to 0. Move things around so it's set equal to 0. So number 2, letter A, is going to be x squared minus 4x less than 0. Now I know in an x squared problem there's going to be 2 dots on the number line. I just need to figure out where they are. So I'll factor. And factoring here, all I'm going to do is take out an x. Now, if you paid attention when you looked at practice test 1, you know there was a problem exactly like this on practice test 1. There will be a problem exactly like this on on your real test that you're going to take. So let's make sure that we follow the logic here. We're going to factor this. GCF, greatest common factor, is x. That tells me I'm going to have a 0 and a 4 as my dots. My dots are at 0 and 4. Now I'm going to pick any number I want. Oh, I might try 5. And I'm going to put 5 in. Now 5's right here. So I put 5 in, and I would get 5 times 1. Is 5 times 1 less than 0? No. So this doesn't work, which means this does and this doesn't. So my answer is everything between 0 and 4. Notice that I did not color my dots in. I didn't color my dots in because there's no or equal to in this problem. All right, next. Just exactly like the one we just finished, I need to start by getting my 0. So over there, I subtracted 4x. Here, I'm going to subtract 3. I have to have a 0. Now I've got my 0. But this is a little bit harder now because I've got a couple of fractions. And I need to subtract those fractions. And the only way to subtract fractions is to have a common denominator. So I'm going to multiply the top and the bottom here by x minus 2. I'm going to get my common denominator, in other words. Now, both fractions have an x minus 2 on the bottom. What do I have on the top? Well, I'm going to write one fraction now, so I'm going to put the top all together. So I have an x plus 4. All right, now watch it here. You're going to do your distributive property. So it's minus 3x plus 6. So now we can collect like terms. So we have an x minus 2 on the bottom. And up here I have a negative 2x plus 10. Now I have a numerator and a denominator. I have 2 x's in my problem. So I'm going to have 2 dots on the number line. And one of the dots is at 2. That's easy to see. I can see I'm going to have a dot at 2. I'm going to have another dot from the numerator, and I'm not sure where it is. So over to the side, I'm going to figure it out. I'm going to figure out where to put the dot by solving the numerator. Set the numerator equal to 0 and solve it. And that dot happens where x is 5. So I have a dot at 2 and a dot at 5. Those are my dots. Now you are tempted, because you see an or equal to color in both of those dots. But remember, denominators can never equal 0. So even though it says or equal to, the denominator won't equal 0. So that 2 has to be left open. The numerator can equal 0, so it's okay for the top dot to be closed in. but the bottom dot will never be closed in. Denominator dots are always open, no matter what. Okay, let's pick a number. Now, be careful. I like to pick 0, you like to pick 0, we all like to pick 0. But when we pick 0, we got to pay attention to where 0 is on the number line. 0 is not here. Some of you like to put 0 in the middle, and that's fine, but it's not right here. 0 is over here. So I'm going to go ahead and try the number 0, but 0's over here. When I put 0 in, I get 10 over negative 2. Is that greater than 0? Is that number bigger than 0? No. So that didn't work, which means this does and this doesn't. So my answer is 2, 5. The 2 is parenthesed and the 5 is bracketed because the 2 is not included because it's a denominator dot, but the 5 is included. Again, the number 0 did not give me a positive answer. So that section of the number line didn't work. All right, C. This is one of these wacky ones with the squared in it. Remember, if it has a squared in it, you cannot do your alternating trick. You're going to have to check every space. So the good news is it's already factored. So you don't have to do that. So you have a dot at -3 and a dot at 3. Since there is an or equal to, we'll go ahead and color those in. And I color both of them in. Kids, don't get confused. There's no denominator. So if it's an or equal to, it's all colored in. The only time you worry about it is with denominators. Now, because of that squared, there is no shortcut. You're going to have to pick a number here, here, and here. So we're going to pick 3 different numbers, one here, one here, one here, and see if they give us the kind of answer that we wanted. So I'll pick a number out here, like -4. -4 would give me -4 plus 3, that's -1. -4 minus 3 is -7 squared is 49. -1 times 49, is that positive? Nope. All right, now I'm going to try a number in here. How about 0? 0 gives me 3 times -3 squared, which is 9. That gives me 27. Is 27 bigger than 0? Yep, so that one works. All right, let's try 4, the number 4. 4 plus 3 gives me 7. 4 minus 3 gives me 1 squared is 1. 7 times 1. Is 7 times 1 bigger than 0? Yep, that one works too. So what did I end up coloring in this problem? I ended up coloring everything from -3 all the way to infinity. So -3 is bracketed. Remember, your infinities are never bracketed. So -3 to infinity is your answer. All right, next page. Here we go. I'm sorry about the staple job here. I think I'm going the right direction. Yeah. Okay, so next, we have another inequality that does not have a 0. So remember, if they don't have a 0, you're going to give them a 0. So x cubed plus 4x squared plus x minus 6 less than 0. So I'm going to add x to both sides, subtract 6 from both sides, so that I have an inequality. A 0. Of course it's an inequality. I need a 0. Okay, now, this is going to have 3 parentheses, gang. 1, 2, 3. How do I know that? Because it's a cubed. How am I going to find those parentheses? Well, I don't know. We got some options, but really we don't. because I would love to factor by grouping, but this one isn't going to group. So we really don't have a choice other than to guess and do synthetic division. Do our PRRs and synthetic division. Now, if you did practice test 1 already, then you know there was one just like this on practice test 1. There is one like this on practice test 2, obviously, and there's going to be one on your test like this. So make sure you review the process. If you've forgotten, review the process we go through when we have to guess and divide. So I'm going to guess the number 1. Actually, I already checked it. I plugged in 1 and it gave me 0. So I'm going to divide that out. I'm not taking the test with you, so you're going to have to do that work on your own. You're going to have to plug in 1 or plug in 2 or plug in whatever you want to plug in that's a factor of 6. 1 is the easiest choice. I'm going to try 1. I'm going to divide it out now, and with any luck at all, I'm going to get a 0 remainder. There it is. There's my 0 remainder. If you guess a number that doesn't work, then guess another number. Keep guessing numbers until you get one that works. I promise it's not going to be something wild and wacky. You're going to, if you're guessing and working it out right, you're going to guess it pretty quickly. 1. Okay, I'm left with x squared plus 5x plus 6, which factors as, watch it now, be careful. Make sure that when you factor, you go ahead and FOIL it back out to make sure that you have factored correctly. So 2 of my factors are x plus 2 and x plus 3. Wait a minute, I'm supposed to have 3. Where is that third factor? Don't forget the third factor. You gotta have 3. Where is he? Right here. He's the one you guessed. So that third factor is x minus 1. That would give us dots on the number line, 3 dots on the number line at -3, -2, and 1. The number you guessed is the dot on the number line. All right, let's pick a number. We'll try 0 again. We can use zeros right in here. So if I put 0 in, I get 2 times 3 times -1. 2 times 3 times -1 is -6. Is -6 less than 0? Yeah. So this section actually works, which means this section won't, and this section will. Now just time out for a minute. How did I get away with only one test number here, and over here I had to do all of these test numbers? The difference is right here. If you have that, you have got to do all the test numbers. If you don't have any of those squareds, there are no squareds here on these factors. If you don't have any of those, then you do not have to check each space. Can you? Absolutely. If you want to check each space, but you don't have to if they're not squared. They will alternate. So my answer, everything from -infinity to -3, or everything from 2 to 1. And notice that nothing is filled in because there's no or equal to in the problem. So everything is parentheses, no brackets. And we're done. Awesome. Now we have E, which is a different kind of problem, and easy actually. E is easy. F's a little tougher. When we solve an equation like this, and note it is an equation, so I'm not doing a number line, I'm not doing dots, I'm not doing shading, I'm not doing any of that. I want to get rid of these denominators. So what am I going to multiply by to get rid of these denominators? I have an 8, a 4, and an x. What will clear them all out? lots of things, but the easiest thing is 8x. So I'm going to multiply everything by 8x. And before I do anything else, some of you get crazy and start doing weird stuff. Don't, stop. After you've multiplied everything by 8x, cancel. Every denominator is gone. You should not see a denominator. All you have left is 16 plus 6x equal to 9x. So 16 equals 3x, and x equals 16 thirds. That is all there is to it. Do not make it harder. Same exact idea with problem F. As I copy F down, I am going to factor this denominator as I copy it down. Remember, our common theme is, if it factors, we should factor it. So I'm going to go ahead and factor that guy. Here I am. Now I'm going to go through with my purple marker, and next to each one of these, I am going to put my common denominator. And my common denominator is x plus 5 and x plus 3. So I'm going to write that down next to each one. X plus 5, x plus 3. And before I do anything, because some of us are going to get excited and we're going to try to multiply. Don't, stop. Slash away. Gone. Every denominator is gone. You have no more denominators. What you have is a distribute right here, 2x squared plus 6x. Now be careful here. This is a little bit tricky. This is all gone. So this is all you have left. But remember, it's being subtracted. So it's going to be minus x squared plus x plus 10. When you do this subtraction right here, that minus distributes all the way through. So minus x squared plus x plus 10 equal to 3x plus 15. We have a little distribute going on over here. Now let's collect like terms. I got a 2x squared and an x squared, so that's going to be x squared plus 7x plus 10 equals 3x plus 15. So I collected my like terms here. I had a couple of x squareds, a couple of x's, so that's what I ended up with. Now let's get it set equal to 0. Move everything over. So I have x squared plus 4x minus 5. Move everything over, get it set equal to 0, because that's what we like to do with our quadratics. And then what? Yeah, it factors. Now, if by chance you get one that doesn't factor, then we'll have to use the quadratic formula or something. Complete the square, something. But this one factors, so x equals negative 5 or x equals 1. My little extraneous radar up, because what do I notice about negative 5? Can I put negative 5 back into this problem? No, I cannot, because it would give me a 0 in the bottom. So the only answer to the problem is 1. Remember, from the beginning, you can tell that -5 and -3 are not going to work. They're excluded values. They'd be vertical asymptotes. They aren't going to work. So if you get one of those numbers as an answer, you have to throw it out. All right, all we have left are a couple of word problems. We're going to do great with these. These are easy. We've done a lot of them. Number 1 is a work problem. We got Jane and Maurice doing something here, building a building. So our formula, 1 over alone plus 1 over alone equals 1 over together. And I'm going to go ahead and take a minute and write that down, because I got some numbers in my problem and I have to know where to put them. I have a 4 and a 6 in my problem. So what's the 4? Jane can build a shelter in 4 hours. So that's Jane's time alone. Maurice takes 6 hours. So here's Jane alone, here's Maurice alone. Now I want them to do it together. How long would it take them together? That's X. This is exactly like a problem we did a little while ago. We need to multiply through by whatever it takes to get rid of a 4, a 6, and an X. There are lots of numbers that'll get rid of a 4, a 6, and an X. The smallest one is 12. Does it make a difference what number you use? No. Find a number that'll get rid of, cancel out, a 4, a 6, and an X. You could use 24, you could use 48. I'll use 12 because it's the smallest. And before I go anywhere or do anything, I'm going to cancel. So 4 goes into 12 3 times. 6 goes into 12 twice, and the X's cancel. You must get rid of your denominators before you take one more step. What do I have left here? Look at that. 1 times 3 times X, that's 3X. 1 times 2 times X, that's 2X. 12. So 5X equals 12, and X equals 12/5 hours. So it takes them 12/5 hours to build the shelter together. One more problem, and you know exactly what it's going to be. It's going to be amount times percent plus amount times percent equals amount times percent. So here we go. Amount times percent plus amount times percent equals amount times percent. What are my percentages? 54%, 45%, 49%. One of the numbers will be known, and it is 6 quarts, and the 6 goes with the 45. How much 54? This is X. The empty spot's down here at the end. When it's at the end, it's 6 plus X, right? You're adding them together to get the total amount. You're adding those two together to get the total amount. So here we go. I'll get a little calculator help here. So 0.54X plus 2.7 equals 2.94 plus 0.49X. So let's move this guy over here and move this guy over here, and I'll divide. Looks like 4.8 gallons. Or quarts. What was that? Quarts, not gallons, it's quarts. And there we go. Practice test 2 complete. Hope you're having a great day.